This is homework 7, question 7. So z of t is equal to n1t cosine omega c plus theta plus n2t sine omega ct plus theta, where theta is uniformly distributed in 0 to 2 pi, and n1t and n2t are WSS. So n1t and n2t and theta are all independent. So question A asks about find E of z of t. So n1t and n2t are WSS. So E, which means E of n1t is equal to n1, E of n2t is equal to n2. So E of z of t can be written as, because z of t is equal to this equation, so we can written as this part. And E of this part can be split. So first split this part. So E of this part plus E of this part, and then split up E of this part times E of this part plus E of this part times E of this part. So we can written as E of n1t times E of cosine omega ct plus theta plus E of n2t times E of sine omega ct plus theta. So this part can be written as n1, and this part, because it's same as 1 over 2 pi integral 0 to 2 pi cosine omega ct plus theta d theta, and this part can be written as n2, and E of sine omega ct plus theta can be written as 1 over 2 pi integral 0 to 2 pi sine omega ct plus theta d theta. And as we know that integral of cosine from 0 to 2 pi is equal to 0, and same as sine, so both 0, so 0 plus 0 is equal to 0. And question B asks about find RZ T1 T2 is RZ WSS. So RZ T1 T2 is equal to E of Z T1 Z T2, which is equal to E of, because this ZT1, ZT2, based on this equation, we can write these messy equations. So it's n1t1 cosine omega ct1 plus theta plus n2t1 sine omega ct1 plus theta times ct2. So n1t2 cosine omega ct2 plus theta plus n2t2 sine omega ct2 plus theta. So we multiply each part. So first this part times this part, and this part times this part. This term plus times this part plus this term plus times this part. So we can write as these messy equations. And because tau is equal to t1 minus t2, so we can write as Rn1 tau E cosine omega ct1 plus theta times cosine omega ct2 plus theta plus n1 n2 E of cosine omega ct1 plus theta times sine omega ct2 plus theta plus n1 n2 E sine omega ct1 plus theta times cosine omega ct2 plus theta plus Rn2 tau E sine omega ct1 plus theta times sine omega ct2 plus theta. And which is equal to half of Rn1 tau integral of 1 over 2 pi, and this part can be getting from this part, also same as this part, and this part. So we can write integral of 0 to 2 pi cosine this part plus cosine omega ct plus half of n1 n2 1 over 2 pi integral of sine minus sine part, sine term, plus 1 over 2 n1 n2 times 1 over 2 pi integral 0 to 2 pi sine of this part plus sine of this part minus half Rn2 tau in times 1 over 2 pi integral of cosine part plus 2 theta minus cosine part. So this part can be transferred into 1 over 2 Rn1 tau plus Rn2 tau cosine omega c tau which is Rz of tau. So question C asks about to find Rz of 0. So if Z of t is WSS. So Rz of 0 just written as this inside. So we can get half Rn10 plus Rn20, which is half E of n1 squared t plus E of n2 squared t. This is question 7.